fixing it with a metal fitting, like you got your discharge tube and it broke, or you broke a fitting or whatever, and you just want to stick a piece of bronze hose barb in there and just let it run. There's the potential you could come back the next day and that hose barb would be gone and the liquid's just hanging out on the ground. And what's worse is that flecks of metal oxides are going to end up in the tank and degrade the whole tank. And that's true of sodium hypochlorite and virtually any super strong oxidizer like hydrogen peroxide or ferric chloride. Ferric chloride will find its way through any metal in a day. If it knows where there's a piece of metal, it'll turn it to dust in a day. So, the corrosiveness, okay, so the corrosiveness, not just your skin, but the materials of construction, and the inverse of that, are the corrosion products detrimental to the product itself? Yes, okay. Another thing is that scenario where the green cloud of death has filled your containment. The gas, the chlorine gas that's settling in that containment is corrosive. It's going to corrode all of the metals in there. It's going to corrode the I-beams in the building. Again, if you get the gas on your skin, it's going to react with the water on your skin and cause irritations. It's going to get in your eyes. My respirator is a full face respirator. I've been fit for it. I know how to use it. It's got the right cartridges. And I'm still very hesitant to do anything outside of what I'm comfortable doing, obviously. In general, my response is above grade, 100%. I'm never going below grade. I'm not going in a containment that's full of bleach. And what I'm mainly doing is transfers, sodium bisulfate, the kind of stuff you need a respirator for. Where were we? Inhalation hazards. All right, we kind of beat that, inhalation hazards to death. That's really the concern that we have, right? Get it on your skin, you're going to be fine. Get it in your eyes, you're not going to have a good day, but you're going to be fine. Inhalation hazards are what's really going to cause you to take a ride in an ambulance, right? This presentation is written for all of the stuff that we sell. Freezing point's not an issue here with what we're talking about, but sodium hydroxide freezes at a fairly high temperature, up to 50 degrees Fahrenheit. And sodium bisulfite, 38% sodium bisulfite, freezes at very high temperature. Possibly, it starts to go at 60 degrees Fahrenheit.
We don't have it outside anymore.
Yeah. Well, right, even if you're just using it in the summer months, it's still right on the edge of freezing. And it doesn't necessarily freeze in the big tank because it's got that thermal mass, but in the tubing, can be a problem. And then when it freezes, then you got to go in there and break, and it stinks, and yeah, that's not good. Not a good option. Auto ignition potential. Again, I wrote this for myriad of chemicals. Secondary thermal reactions, we talked about it briefly. If there's a fire in the building, how are the chemicals that you're using in that building, how are they stored, how are they going to react with a fire? How are they going to react with the firefighting measures that people are going to shoot in there? Potassium permanganate, pretty commonly used in wastewater. Potassium permanganate is a solid, it's a glassy purple crystal. Small amount of water in potassium permanganate has the potential to auto-ignite. And when it auto-ignites, when it actually goes into the conflagration phase, it generates its own oxygen. So there's really no way to put it out. Like you can't put the cover on and have it go out because it's got its own oxygen. It's a little rocket engine. And spraying it with a chemical extinguisher or a carbon dioxide extinguisher is not gonna work. The only way to put the fire out is to flood it with water, get it down to the, dilute it down to a concentration that's not reactive. All right, I think we've had enough of that slide. All right. I made this point in the other session. I'm going to make it again this session. 15% trade concentration is exactly the same product as 12.5% by weight. It's the same thing. It's on, I know it's on the paperwork everywhere, and no matter who you buy it from, some people call it 15%, some people call it 12.5%. It's the same stuff. It's not more concentrated at 15. 15 is the trade percent, which is volume to volume, and 12.5 is what we add it. It's how we add it. And if you take 15 and you divide it by the specific gravity, which is 1.2, you get 12.5. And you take 12.5 and multiply it by 1.2, you get 15. It's the same number. It's just, I know it's confusing, and I wish it weren't the case, but the product you're using is 12.5% by weight. And the reason it's that weight, the reason it's that concentration is because of the exponential decay of strength. Above 12.5%, it is what we call hot, right? And it decays very rapidly. So everybody around here buys 20% sodium hypochlorite, either from Canada or New Jersey, and they bring it in as fast as they can. And as it's coming out of the 20% tanker, we're diluting it as it's going into our storage tanks. And we dilute it down to 12.5%. We test it, and then we ship it. And especially from Carthage, we get 6,000 gallon, well, I shouldn't say that, 112,000 pounds over the road is. The maximum overweight tanker we can get over the road, it's about 6,000 pounds of 20% sodium hypochlorite. We get 2 to 3 of them a day in Carthage. And we dilute them down as they're getting unloaded, test them in the tank, we load our tankers, and we come down here. In the summer, the bleach that you buy was in New Jersey or Canada the day before you get it. It's not old. It's very new. We run through our entire stock every day. Again, that's why it's 12.5%. Again, I like to say everything twice. Sometimes I say things 5 or 6 times, but Hastelloy and titanium are the only metals that can come in contact with sodium hypochlorite. If you want to challenge me on that, if you've got some super special stainless steel that you think will stand up to it, I'm more than happy to discuss it. But I've had that discussion with an engineer before. He assured me that his super special stainless steel was going to stand up to that, and it did not. And they had to clean up the mess. Again, don't acidify it, talked about that. And because as it degrades, it's just a natural degradation over time. There's certain things, obviously, that speed up that degradation. Heat is not good, so it goes off faster in the summer than it does in the winter, which is ironic because that's when everybody uses it. UV exposure makes it go off a little bit faster. Any kind of contamination that we talked about is going to accelerate that exponential decay. It does produce oxygen as it decays, and you can, if you contain it in a specific closed piece of plumbing, you can produce yourself a little pipe bomb. And when you decommission pieces of plumbing, like if your system has some PVC pipe that goes from here to the other side of the whatever, when you're done sending chemical through it, wash it out and leave the valves open, because there is the potential that confined chemicals can produce their own gas and pop. I didn't know that that was a case. I mean, you can say that and tell people that, but until you've actually seen it with your own face, you're like, that'll never happen. Well, we had a customer. If you think about a ball valve, right, on the bottom of a tote, it's a big thing like this, and inside there's a ball, and the ball has a cylinder cut out of it. So it's a ball with a cylinder cut out of it. And when the ball is in this direction, the product's allowed to flow through. But when you turn the ball valve 90 degrees, the cylinder's this direction, and it doesn't allow product to flow. Well, you just confined that product in that ball, right? It's got nowhere to go. If it outgasses, what's it gonna do? I don't know.
We spec out drill ones, not
Yeah.
to ruin your story.
No, you're 100% right. If you have an oxidizer, if you're buying an oxidizer, you drill out the product side of the ball valve, so when it's closed, there's a hole that allows it to outgas. Well, we had a customer who did that, and it wasn't drilled out, and it's a small volume, and it doesn't make a big pipe bomb type situation, but it did ruin the valve and broke the tote and all the things that go along with that. But again, if I hadn't seen it with my own eyes, I would have thought that was kind of a non-problem, but it is a problem. It can be. Again, we're not going to expose it to ammonia. All right, so I'm going to go through. It's shocking how long it takes to go through this one. I'm going to get the sodium hypochlorite SDS sheet up. All right, briefly, GHS is Global Harmonization System. What the regulatory groups decided was that we should have a formatted SDS sheet that is the same format, the same type of information, in the same order for all chemicals, for all suppliers. Okay, great. This is true of North America. This global harmonization, as global as global gets, essentially Canada and Mexico. So if you drive from Canada through the US into Mexico, you can have the same bill of lading, the same SDS sheet, the same transportation documents. That's essentially what this global harmonization was supposed to garner us. First thing is the product name, and I beat this to death, but the product name obviously is the most important thing on an SDS sheet, and you'd be surprised how hard it is to find the product name on certain proprietary chemicals. Like, pull out your polymer SDS sheet, try to find the name, the exact product name from your dewatering polymer. It's pretty impossible. There has to be some identifier on here that's exactly the same as the labels that are on your tank and the shipping documents that are on the bills of lading. You have to be able to correlate these, and if the OSHA or the Department of Health or the DEC comes in and says, show me the SDS sheet for that, you have to have a way to get that. And the SDS sheets should be available to everybody that's involved in the process that has that. Again, if an inspector comes to an employee and says, where's the SDS for this? You should be able to, you don't necessarily have to produce it and show it to them, but you should know how to get it or where it is. It gives you, in this case, acceptable synonyms for sodium hypochlorite. And we talked about it. Because we sell this into a lot of different industries, we sell it as bleach 15%, bleach with added alkali, bleach with added alkali, hypochlorite solution. I'm not in love with that because calcium hypochlorite can be put into a solution, but we had to put it on there. Pool shock, definitely pool shock is sodium hypochlorite. Superchlor is our trade name, as we discussed. Superchlor 15 is our NSF certified potable water product. Superchlor shock, again, shock is the same thing. This is a chemical formula. Nobody's going to know that. Don't use it. It's not important. CAS number, CAS number, Chem Abstract Service. Chem Abstract Service. When you see a tanker going down the road of sodium hypochlorite, it's going to have a placard on it. That placard is a UN number. The UN numbers are somewhat ambiguous. They can be somewhat ambiguous. 1791 is sodium hypochlorite. It happens to be sodium, unambiguous sodium hypochlorite. But when you get ferric chloride or ferric sulfide or polyaluminum chloride, the placard that's on the tanker has a UN number that is not exactly what it is. It's a group of chemicals. It could be this. It's a group of chemicals. To get rid of that ambiguity and have a sortable number system, the Chem Abstract Service gives you that number. And that number, if you just put in CAS and that number into any search engine, it'll give you exactly this information. So in the computer era, when everybody wants to sort everything, you can sort by that Chem Abstract number. And it is a unique number to each chemical. These are the uses, product use. If you are using it outside of what is on the SDS sheet, you are in violation to some degree of the spirit of this whole process. It has wastewater treatment, potable water, you're okay, because that's what you're using it for. If you're using it to kill bees in the yard and the DEC finds out about it, they're not going to be happy. The world's not going to come to an end, but that's not what it's used for. This is our address. We are the manufacturer supplier. This is our phone number. After hours, we have an after hours service. Believe it or not, there's a human being that will get that information. Long story short, if you get our after hours service and you leave a message, someone from our company who knows something will call you back fairly immediately. That's our commitment to our customers. We get back to you. Barring that, catastrophic, whatever, disaster, or you have outside people coming in to respond to a chemical emergency, there is information available from Chemtrex. Chemtrex is a non-for-profit organization that we as a chemical distributor pay into. They provide emergency response information and potentially logistics if necessary. Call that number. I've never had to do it. I don't know what happens when you call that number. You're much better off going through that number, handling it internally, going through your management, making some informed decisions before going to this level. This is definitely a management level call, I would say. So the global harmonization classification hazard identification, that's a mouthful. This is what we have to provide on the labeling and on the shipping documents. These are the witness stickers that should be, again, global harmonization is kind of like, it's as harmonized as it's going to be. We made a lot of progress from where we were, but we're not 100%, with all facets. This is more of a transportation type document at this point. The way you label your tanks and the way you label your fill points and all the labeling that you do internally, is kind of regulated by the DEC or the EPA or OSHA, and it's your responsibility to get that right. The suggestions are here on the SDS sheet, but you'll get another, every time you get inspected, you'll get another suggestion from another inspector. It is, I mean, there's no way of getting around it. It is a biohazard. I shouldn't say that. It's toxic to the aquatic life. That's what that dead fish and dead tree mean. Yeah, if you spill a bunch of it into the environment, you're going to kill fish and trees. It is pesticide after all. Yeah, there's a long list. And then the composition. In this case, we're not trying to hide anything because everybody sells the same product, right? It's sodium hypochlorite, sodium hydroxide, and water. We only have to disclose the hazardous ingredients in this section of the SDS. So if you have a mixture, a proprietary mixture from somebody else, there could be 2 hazardous ingredients and 2 non-hazardous, and the non-hazardous ingredients may not be listed here. But for our purposes, everything we sell you is dissolved in water. So these are the only 2 ingredients other than water. So it gives you the first aid measures. We talked pretty much on end about that. If you get to the point of your respiratory distress, that you're coughing and there's congestion in your lungs, I definitely would think about going to occupational health and having somebody take a look at you. I've gotten to the point where it was really painfully bad and didn't go, but I was a younger, stupider person in those days. Like I said, the calcium hypochlorite accident I had, I chose not to get treatment, but if I did that again, if I had that situation again, I would definitely just go to occupational health and just have it looked at. There's no downside of that. Everybody makes mistakes. Everybody does something stupid in their life. Get it out there in the public and learn from it. We talked about getting product in your eyes. This is true of everything you get in your eyes from a chemical standpoint. Stick your head in the eye wash as long as you can. And depending on what it is that you got in your eyes, you may want to stay in there until the EMS arrives. In the case of a splash of sodium hypochlorite, you can probably make it to occupational health on your own with some help. You're going to want to wash anything that gets on your skin, take off your clothing, any soaked clothing. And we're not going to discuss ingestion because nobody's going to do that. Know that there's any special firefighting measures associated with this. No unusual fire explosion hazards during fire gases. All right, that's what we did talk about. Any acid or heat can accelerate the decomposition and cause that chlorine gas to come on. Accidental release measures, again, is above my pay grade. That reporting and responding to accidental release measures is a management concern. It's not something I get involved with. Once it's in the environment, I can't help you. If it's in a containment, if it's inside the building, if there's a way that we can support reclaiming or renovating, that's not what I'm saying.
Remediate.
There you go. That situation, collaboratively with you guys, we're more than happy to help you out. But once it goes into the environment, you know, we have the same responsibility. If we have a tanker that loses some product on the ground, we're under the same rules that you are. Again, handling and storage. There's two things going on with personal protective equipment. There's what am I required to wear by the management? What am I required to wear to keep my job, not get written up? And what do I want to wear to make sure that I'm not exposing myself to undue hazard? Again, from my personal experience, I wear, if I'm unloading a trailer, if I'm transferring large volumes, if I'm working on a pump system that has the potential to put large volumes out, I'm going to wear hard hat, shield, goggles, jacket, bib, boots. The jacket goes over your gloves because you got to think about getting a bath. How is the liquid going to run? If your jacket's tucked into your gloves, it's just going to go into your gloves. If your pants are tucked into your boots, it's going to go into your boots. So put your boots on and your gloves on, and then you put your suit on. Again, if there's the potential to put a large volume in the air, I'm going to wear goggles because I've done it, and this is how I got. I got a lot of learned knowledge, experience. Taking apart a small diaphragm pump, and I just cracked the fitting and shoot you in the face. And there's nobody that can just aim their head at it. Everybody's going to turn their head when they do it, and then it goes behind the shield and inside your glasses. So I still wear the shield, I still wear the helmet, but I have goggles that are a little bit more protective than just safety glasses. And again, there are different environments that call for a different amount of protection. There's times when I'm working on a pump that I know is vented and it's sitting on a desk, and it has product in the head that I can wash out. No, I'm not. There's no potential for it to be shooting across the room. Then my choices are different. But if there's the potential to take a bath, I'm going to take every precaution to wear all the clothes that I can. Engineering controls. All right, we're going to go down to engineering controls. This is maybe more relevant or pertinent to other chemicals, but how do we make sure that our systems are well designed, well ventilated? One of the things that I see all the time are poorly vented tanks that we're getting deliveries of ferric chloride, for example, and when the tanker truck blows off that last bit of air, before the operator gets there to shut the valve, that mist, that aspirated mist, floats around in the room, and it ends up on the beams and on the siding, and over time, it just turns that building into dust. There's a certain amount of atomization that you can get in sodium hypochlorite in that same situation. You as operators have a certain amount of responsibility, and our driver as a delivery person has a certain amount of responsibility not to allow a huge amount of air to go from the delivery tanker into the tank and into the building. Even if you're vented outside, you really got to consider getting to the tank